Welcome to the Easy Access 1 Java tutorial series. This is Project J1A. Project J1A is going to be a Java-based email web proxy filter. From the beginning of this tutorial to the end, you will go through an entire build of an end-user product that one might use in a corporate environment. I'm going to build this from scratch. That means I'm not going to contain any Java compilations or any other jar files other than what would be absolutely necessary. For instance, JDBC, connection driver or connection manager, something maybe written in C++ or some other object that simply is going to be native to one of the computers that you're dealing with, one of the operating systems. Other than that, this is going to be bare-knuckled, straight up, hardcore. This is not the hello world. This is going to be a complex, multi-threaded, object-oriented, hierarchical composition. Let's get started. Chapter 1. The basics here, I will slow down just for a bit. Let's go over Eclipse. Let's go over how I've got my Eclipse set up, what version of Java, so forth and so on. So let's start there. I have this Eclipse set up on a Windows 7 machine right now. I prefer Indigo. I'm not going to be doing any Android development in this, so we're going to stick with a typical Java project. I'm running JDK 1.8 build 111 today. This is 3.7.2 of Eclipse, and the only real configuration you can do without a project open is set your class path, I believe, and play with your appearance. None of that matters to me really. Here's where you would possibly set your runtime environments and set anything that pertains to this particular version of Eclipse that we're running right now. I'll give you just a second to look over my Eclipse INI. An Eclipse INI file in Windows is the startup file that Eclipse uses to launch itself. Believe it or not, Eclipse, to my understanding, is actually written in Java. So in order to run Eclipse, you have to load the jar files. The VM that Eclipse is using has parameters, the XMS and the XMX parameters. If you don't know what those are the minimum and maximum amounts of memory that the JVM is allowed to use. That's just the current setup that I'm using. If you want to mimic this so that you can build along with me, you're more than welcome to. All right, let's look back at our index here. Let's get into the static main. Everyone should know this. I'll go over it very quickly. In order to do a static main, we're going to need a Java project, an Eclipse project. In this project, I'm going to call it Proxy project. I'm using the default JRE that comes with build 111, JRE 1.8. In here, this is where in the future you may add your jar files. This is basically like configuring the command line for when you run Java W or Java, or even Java C. And here's where your system libraries would be located, and any other projects or any other JRE files or any of the class files that you need to load that are external need to be put in here. Okay. Okay, did that again. Hit cancel by accident. No big deal. I'm going to create a package called Proxy package. For any of you who don't know what packages do, they basically give you like a little corral. place to reference your project. If you're going to build your project into a jar file, or you're going to export your project here, you need a package name in order to kind of create your manifest. I'm going to create my class. This is going to be my loader class. I use a loader. I'll give you a brief explanation of why I use loader classes. If I ever want to escape the public static nature and get into instance-based programming, you can't really do it in your main file, in this case your loader, because you're stuck in your static void main. And what I like to do is actually create the instance of my object, or my deliverable, or where I'm going to start my programming, one layer down from this loader. I'll use this loader to instantiate, and everything I'm doing right now would be specific to this machine. Right about here, we're going to hand off to solely a programming situation. You'll see me using the tools, the compiler, the debugger. Those would be specific to this machine I'm working on right now. I'll show you how to get around that with some debugging and some system out calls. Otherwise, let's get going. Waste your time, and we will start by getting our public static void main going. This is very basic stuff. If I've lost you at this point in time, you need to look at some other tutorials first on how to compile. You really should be past compiling from command line. You should understand the concept of a shell file or a batch file, or shell script or a batch file. You should understand the syntax versus runtime versus syntax errors. I'm just going over this briefly. Inside my public static void main, I like to create the entry point for my programming, which I'm going to call proxy controller. Currently, that's not going to mean anything because I don't have a proxy controller class file yet. So I'll create my proxy controller class file here. Eclipse creates that, and you'll see we now have the handoff between the operating system, which will come in. The operating system will call Java runtime environment. The Java runtime environment will call the public static void main. It'll pass a string array called args in this case, but it passes a string array of any name. But the args, ARGS, in this case, string array, is going to be an array of input parameters that came from the command line. You're not going to see much of the command line when you're in Eclipse, but if you port your projects around like I do, I'm very quickly copying and pasting and connecting and emailing and moving my projects around to, for instance, a Linux machine. And as soon as you get to a Linux machine, you've got a different command prompt. You've got a shell, you've got a bash, and you've got to instantiate your version of Java, and your arguments may or may not be exactly the same place, but they're generally going to be the same. So we've got our new proxy controller and an args, and in the proxy controller I'm going to create the proxy controller constructor, if you will. So this is the class definition for proxy controller. You'll notice there are no parentheses on a class because a class doesn't take parameters generally, or I don't know if any way you could probably pull that off. Your proxy controller here will fire when the class is constructed. If you put void in there, if you try to make this return a string, it won't. You create a different polymorphic class, and you'll end up having to call that specifically, and it won't be part of the constructor. At this moment in time, I'll just briefly go into system out. system out is a system parameter. It's a system object that relays information back to the original command prompt that you may have launched this from. In this case, system out is redirected to a tab called console down here. See these tabs? Eclipse gives you a console tab, which is the embodification, the creation of a command prompt. So to access that, you do system out, and that gets you to your console, and you could print line, simple as that. And now you can see that we have interjected the characters hello world into the console or the system out. So now we know that the operating system has created the JVM. The JVM has called the loader class. The loader class has exposed the system. Back here. The public is exposed to the system the public static void main, passed the arguments, and in this method the proxy controller object has been created. The proxy controller object is a class which opened the constructor, and the constructor has printed the system out hello world. So we have a successful, we have now created the framework for a successful launch. It does virtually nothing at this point, but we do have a functioning product at this point. Okay. We have gone over the Eclipse setup. We have created the public static void main. We have created and linked our first class. We have gone over the basics of creating our first class. Now let's get into really quick, believe it or not, the word public, not so sure about public on class, but the public on the method is actually an optional public word. Anything that doesn't have the security definition in front of it, public, private, serialized, etc., etc., it's assumed to be public. Now, public can be called by objects outside of the class. So in this case, proxy controller is a public constructor. Now you might make a public string called status. You now have a string that can function with objects outside of the class. One way to get a handle on the mayhem here is to create a private string. And a private string would be accessible only by the methods and the programming inside this class, being the proxy controller class. Now let's go over this concept of private strings. Right now we'll have a small error from Eclipse saying, hey, you never used. This is almost like an optimizer. Let's get onto the keyword this. It's actually a reference to an object. This, depending on what class you're in, the letters this, THIS, actually mean different things. So in this case, this applies to this current instance of proxy controller that the program is operating in. So if your current program is running, this becomes a reference to itself. Okay. So right now, this dot status clearly applies to this particular instance of status. Now, the reason we do this is if I were to go to loader and I changed the the way loader worked. And I decided that proxy controller, I want to maintain a reference to proxy controller. So instead of just creating a new proxy controller, I will create an object called PC and assign it to an instance of proxy controller. So now I have an object called PC, and I will call a function in PC, and I'm going to make this function set status. And I'm going to set status to good. Now right now that's going to fly in the face with red because that function method doesn't exist yet. So I'll make a public set status, takes a string called status, and returns nothing, so it's public void. And in this, I'm going to do that. Now let me decode this for you very simply. Set status is going to be a public function, and the public function that's going to manipulate a private string. You'll see this everywhere in Java. You'll see this all over the place. The interesting part about this line that my cursor is on right now is it kind of bends your mind a little bit because I use the keyword, the variable named status, and I'm using the word status, so the text status, the variable status, to assign another variable called status. And this could get very confusing. Probably a better programming concept would have been to use status A or something like that. See how I'm doing there? But that's not how we always do it. I get attached to my keywords. I like my int I, my C, CPP, C++, whatever. I enjoy using my variables in a very consistent way, and as I consistently use my variables, I overlap. So Java provides this neat way to compartmentalize your code. So now we have set the status to status this.status. So we don't need that there anymore. Hello world, and what we can do is we can create another function called DisplayStatus. Okay, see where I'm going with this? And that's going to return nothing, and I'm going to borrow this. I'll do that. I'll do this. This. I just copied and pasted that, and I'm going to show my current status. So I'll buzz back over to loader and set status. You see it magically no longer okay. So set status now became a valid function. Eclipse figured that out just a second ago. So we're creating the object here in void main. I am setting the status to good, and then I'm commanding it to display the status. Okay. So setting status to good, displaying the status, setting the status, which is going to set our private string, and then display the status, which is going to push that out to standard out. So I'll run it. I got hello world. I'm your construction. I'm your constructor. Hello world, I'm your constructor. And the status is good. All right, now I want to talk about try catch. Try, block, catch. Block. That's a valid block. Believe it or not, this line is a totally valid piece of Java code that does nothing currently. Try is a bit of a safety net that we use. Inside the try, variables that are defined inside the try block stay within the try block, unless system got garbage collector says otherwise. That's how they're going to work, and that's how they're supposed to work. So if I was inside my try, I can actually cause a system interrupt failure or some sort of a critical failure that will not terminate my code. For those of you who are into Visual Basic, it's on error, and you override on error resume next would probably be the closest thing I can come up with that would be similar. And this is much more eloquent because in Java, you're on error, go to next, or on error resume next, and on error go to 0 actually refers to some very, very old Visual Basic code that doesn't exist anymore. Maybe does back there somewhere where the line numbers are. But so in this situation, I'm going to define an integer called I, and I is going to equal to 100 divided by 1. And I'm going to show you I. And let me even make it even simpler. I equals, would you please stop doing this to me? I equals I. Okay. This should pass with flying colors. And I will equal 100. Well, that's cool. So here's a problem. What if I were to equal 100 divided by 0? This is going to cause a system failure because Java is not designed to handle infinity. So on run, you're going to see nothing because I haven't defined the rest of the exception. So the magic here is that 100 divided by 0 would normally cause your program to fail. But right now, the system gracefully resumes. But Java, the JVM will encapsulate inside exception E, create an object called E, which is an exception object. This is going to get a little interesting, but in Java, one of the core rules when they created, I think it was Oak before it was called Java, was that anything is going to have to be transcribed into a string. So no matter what the object is in Java, it has to be convertible into a string, represented by a string. Now that has good points and worthless points. The good point is that most of the time when you convert an object into a string and you push it to your system out or your console, you will get something out of that, something that can help you, something that can make you understand what the problem is. If you're trying to track information, you're trying to figure out what the heck is this object is, who created it, what's it all about, you could probably dump it into the console and pull it apart and see something. And if you're in one of these fancy editors like this, like Eclipse, you might even get the debugger to open it up for you and call the methods to see the contents. But right now, we're going to access system out, and we're going to show the contents of capital E. And capital E has been assigned by the system as the exception that was caused by the division by 0. So we're about to see, if everything goes well, we're about to see some fancy explanation as to why you can't divide by 0 in Java. And there it is. Java, lang, arithmetic exception, division by 0. So that's bad. So we don't want to do that. So we want to keep it up there, 100 divided by 1. So these are our tries and catches. Now you're going to see that as we get into the multi-threading, as we get into threads and to socket objects, when I start loading Java to I/O and I start moving into JDBC, and we'll start seeing moving large objects around, consuming blocks of memory. you're going to see that the try catches are not optional. The system knows that there's going to be problems, and they have to be done inside the try catch, especially when we get into system sleeping and we get to holding threads so that we don't cause errors. If you ever do system.sleep, you know that that's got to be done in the try catch, or it won't make it past the compiler. Okay. Before I wrap up try catch, and let me look at my outline here. We don't want to get into throwables. So let's keep it simple with try catch syntax. One thing that's important is that, see this integer here that I've defined inside this try block? That integer is not referenceable outside of the try catch. So that's it. Once we get to this point here, that integer is gone, or at least it's not referenceable. It's probably not gone until the system garbage collector gets it. But keep in mind that your try catches are, in order for them to not fail the system, they compartmentalize. It's almost like their own little JVM in there, but I'm sure it's not. The try catches are designed to work that way. There's also a finally, if you ever want to get into it. And the finally clause will run even no matter what. The finally is supposed to run. So you could do any future debugging in there. So you've got try, catch, and finally. If you want to read more about those, there's lots of information on the internet. I don't know too many people use finally. But if you're dealing with a socket object, if you're dealing with various system resources, you're going to want to let those resources go, especially when it comes to some of the JDBC work we're going to be doing. You have to let the connection management, the connection go, the statement. Those things have to be set to null and disposed of. And if they stay connected, the system garbage collector can't collect the garbage. It can't recycle that memory, and you'll have a memory leak. So you got to be careful. When you create objects in Java, you can lose references to them. They can get spun off, and you can end up with memory leaks, and you can end up having to terminate your executables in order to save the system from crashing if you let them run for months at a time. One more thing I want to go over, it's not on our syllabus here, is a private string I like to define called module. Now I create this string called module. This string would be assigned in Proxy controller in this case. And you could even do this.proxy controller if you want it to be this.module if you want it to be very specific, just to make sure. That I use this so that I know where I am. It's very easy to get hooked into one of these debuggers. Like we'll go into it. I'll be setting breakpoints. I'll be examining code, picking up the watch windows, and we'll be piecing and pulling apart objects at runtime so that you can figure out what's going on inside the arrays. And if you ever set your code up for production and there's some sort of a failure, you won't always know where the failures are. And even the best programmer is going to get hit with a stack trace that looks like a pile of spaghetti, and you can be a lot of Hertzville. So I like to create this string called module, and what I can do is module can be used here in my exception, which is about the only place it's good for, other than some sort of ant logging or SQL logging. If you want to do something like that, I don't know if I'll get into that in this one, but if we cause a system error, now this is runtime error, not a syntax error, because that passed the syntactical checker. It's actually kind of interesting that that Eclipse doesn't catch this, because there is no way that could make it. Now we've got hello world, I'm your constructor. Then we have our exception, division by 0, and then in the second line of my exception, it tells me where the module was, where the failure occurred. And in this case, the failure occurred in the proxy controller initialization, which is basically this area here. So it's just one of my little debugging tools. You're welcome to use it or not. That's up to you. Okay, so I don't care for this. I don't care about any of this. And I like my module. I like my exception error. Sets. I don't have any need for the status stuff. It's just for you guys. And status this. And let me get rid of this. And I don't need. I'll leave that for now. That should still pass the compiler. And it's still a good program. Okay. And it doesn't do anything because our try catch is closed. All right, that's it for chapter 1. Feel free to subscribe or to leave me a message. I don't do a lot of technical support for any of this. I'm sure I've made some sort of error in here. I misspoke something. I appreciate people who are going to correct me. This was just the basics of the J1A project, which is going to be a multi-threaded Java-based email proxy filter that I'm going to be building from scratch. Stay tuned for chapter 2, or click on chapter 2 when the link becomes available, if it shows up, and we'll get into the sockets. Thanks so much. I'm Ben Hujan.